Given question, find out first principal stress and location of principal stress. Second, maximum shear stress, position of maximum shear stress, normal stress at maximum shear stress plane or average stress. Third, normal stress at oblique plane AB. To find out the different parameters for the given diagram, let us first understand the sign convention. For the tensile stress, we will use the positive sign. So we will first show the direction of arrow in the outward direction from this given body, and that is known as the tensile stress. So we will use here the letter T to show the tensile stress. Now next is compressive stress. So for compressive stress, we will use the negative sign. So I will show the direction of arrow towards the body, and we will use the letter C to show the compressive stress. Next is shear stress. For shear stress, there are two directions: anti-clockwise direction and clockwise direction. Now, to understand the anti-clockwise direction, we have to observe the arrow of shear stress for this front face. So this line is important. If the arrow is in upward direction, then we have to show the arrow in the opposite face, that is in the downward direction. So for these both arrows, the direction is opposite. Now if I move the compass in the direction of these two arrows, then here is anti-clockwise direction, and we will use the positive sign. So we will show here the shear stress with anti-clockwise direction with positive sign, and the shear stress is in the complementary form. So we have to show arrows on these two faces also. So if we observe, here is point in the upward direction. So we have to show here one horizontal line, and we have to show point that will meet to this point. Now in the same way, for this arrow is pointing here. So if I draw the horizontal line, then we have to show arrow towards this point. So this is the shear stress is in anti-clockwise direction. Now we will move to the next type, that is the clockwise direction. So again we have to concentrate on this face. So at this time, here the arrow is in downward direction. Now we have to show for the opposite face. So opposite face, arrow is in the opposite direction, that is in the upward direction. Now if I move the compass in the direction of these two arrows, then here is the clockwise direction, and we have to use the negative sign. Now shear stress is in complementary form. So if we observe, for this arrow, it is pointing towards this point. So if I draw here the horizontal line, then we have to show arrow which will point towards this point. Then here this arrow is pointing towards this point. So if I draw horizontal line, then we have to show the direction towards this point. Now I will show here the clockwise direction with negative sign. Now according to this sign convention, if we observe the given diagram, then 45 megapascal is the tensile stress. So it is along the horizontal line. So we will say here sigma x is equal to, now for tensile stress we will use positive sign, that is plus 45 megapascal. Now if we observe 60 megapascal stress, then it is towards the body. So it's a compressive force, and it is along the vertical line. So sigma y is equal to, according to sign convention, we will use negative sign, minus 60 megapascal. Now if we observe the shear stress of 30 megapascal, then we have to observe the front face. So for front face, the arrow is in the upward upward direction. So for upward direction it is anti-clockwise direction and sign is positive. So tau, that is the shear stress, is equal to positive, that is with plus sign, 30 megapascal. Now we will calculate magnitude of principal stress and location of principal planes. So for the principal stress we will get two values. So we will give the notation sigma P1 comma sigma P2 is equal to, and we have formula sigma x plus sigma y by 2 plus minus square root of sigma x minus sigma y by 2 bracket square plus tau square. Now we will put the values. So sigma x is plus 45 plus sigma y is with negative sign, so minus 60 by 2 plus minus square root of plus 45 minus, now here sigma y is minus 60 divided by 2 bracket square plus tau square, tau is 30 square. Now when we solve this, then we will get here minus 7.5 plus minus 60.46. So how to get the first value? For first value we have to take minus 7.5 plus 60.46, that is equal to 52.9, and for second value minus 7.5 minus 60.46, that is minus 67.9. Now we will calculate the location of principal planes, and that's why we have to calculate the angle theta, that is theta p, that is angle for the principal plane. So here we have formula in terms of 2 theta p. So 2 theta p is equal to tan inverse of 2 tau divided by sigma x minus sigma y, and that is equal to tan inverse of 2 into tau, that is 2 into 30 divided by sigma x 45 minus 60. Now when we solve this, then we will get one angle, that is 29.74 degree. So this is the first angle, but here there are two values for this magnitude of stress. So how to get the second value? So we have to take this value in the third quadrant, that is we have to add from this angle 180 degree. So this is the first angle and this is the second angle. Now we want the answer in terms of theta p. So theta p is equal to, we have to divide it by 2. So 29.74 divided by 2 is 14.87 degree, and this divided by 2 is equal to 104.8 degree. Now if we observe, this is the maximum stress, so it is having positive sign, so this is the maximum stress. Now this maximum stress we have to show for the first angle, which is inclined at 14.87 degree. So I will locate here the first angle. So for first angle always show maximum stress, and remaining minimum stress we have to show at the second angle. Now we will understand how to locate the principal planes and principal stress. Now we will first locate the angle 14.87 degree. So there is one rule, we have to always show these angles in anti-clockwise direction from this face. So this is, we will consider as a front face. So we will show the anti-clockwise direction, and if we move the in anti-clockwise direction at an angle 14.87 degree, then we will get this point, and I will draw here one construction line. Now we will move to the second angle. Now the second angle is greater than 90 degree. So how to show that? So for this front face, I will make one construction. I will extend this. Now from this line, if I move in anti-clockwise direction at an angle 104.8 degree, then this angle in between this horizontal line and vertical line is 90. So 90 plus 14.87. So here is the location. So if I take here, if I draw one line passing through this point, this is the angle. Now we will highlight this. So if we observe, angle in between these two lines is equal to 90 degree. Now I will highlight the area. So if I highlight here this line, and this is the point of intersection, so I will highlight this. Now we will draw the lines parallel to these two lines. Now we have to show stresses. Now we have to show stress plus 52.9, that is the maximum stress at an angle which is in the first quadrant, that is 14.87. So this is the first angle. So if we observe, this is the line along this angle. So we have to show tensile stress because sign is positive. So we will show here with the help of this two arrows, that is in the outward direction, and we will show here this 52.9 megapascal. Now we will show the minimum stress at an angle 104.8 degrees. So this is the line. So if we observe here, this is the negative sign, that means compressive stress. So I will show here compressive stress, that means arrow towards the body. Now I have shown with the help of arrow, that is compressive stress. So we have to mention only magnitude without sign. That is, I will mention here 67.9 megapascal. Now we will calculate maximum shear stress and position of maximum shear stress. So how to calculate its magnitude? So we have formula, tau max is equal to plus minus under root of sigma x minus sigma y by 2 bracket square plus tau square. Now if we observe the formula for the magnitude of principal stress, then we have to take here the second part of that formula. Now if we put the value, so we know the value of sigma x, that is 45, minus sigma y is minus 60, that is minus 60 by 2 bracket square plus 30 square. So here is plus minus. So we will get two values, plus 60.4 and minus 60.4. So this plus 60.4 is the maximum value. Now we will find out the position of maximum shear stress. So we will measure this position in terms of angle, and this angle is theta s. But we have formula in terms of 2 theta s. So 2 theta s is equal to tan inverse minus in the bracket sigma x minus sigma y divided by 2 tau. Now for this formula, if we observe the formula for position of principal planes, then we have to take the inverse and we have to just mention here the negative sign. So if we put the values here, so I will multiply this minus sign with inside the bracket. So it will become minus sigma x plus sigma y. So minus 45 plus sigma y, that is minus 60. So minus 45 plus inside the bracket minus 60 divided by 2 tau, that is 2 into 30. Now when we solve this, so I will make here the square bracket. So when we solve this square bracket, then we will get tan inverse of minus 1.75. So when we take tan inverse of minus 1.75, then we will get one angle minus 60.25 degree. So how to find out the second angle? So for second angle, we have to just add 180 degree. So minus 60.25 plus 180 degree is the second angle. Now this is the value for twice of theta s, but we have to find out theta s. So for theta s, we have to divide these two terms by 2. Then we will get theta s is equal to minus 30.125. So this minus 30.125 is the first angle. So remember, so when we take this angle, that is the first angle, and how to select the second angle? When we add it 180 degree, then we will get the second angle. So this is the first angle and this is the second angle. Now to locate this maximum shear stress and position of maximum shear stress, for this first angle we have to locate this maximum shear stress value. So this is the maximum value, and this maximum shear stress value we have to locate at the first angle. Now we will understand how to locate the maximum shear stress. So maximum value we have to take at the first angle, and the first angle is minus 30.125 degree. So when the angle is positive, then how to locate it? So we have to consider this vertical line and we have to move in the anti-clockwise direction to locate any positive angle. But here the angle is negative. That means we have to move in the opposite direction, that is in the clockwise direction. So from this front face, if I move in the clockwise direction at an angle 30.125 degree, then I will get this point. Now I will show this angle with the help of dash line. But this line is outside the body, so I will transfer it inside the body. So how to transfer it? So I will draw here one construction line and I will take line parallel to this, and we have to pass through this point. Now if we observe, angle in between this inclined line and this vertical line is also equal to 30.125. So here is also 30.125 degree. Now what is the magnitude of maximum shear stress? So it is plus 60.40 megapascal. So whenever this is plus sign, that means we have to show shear stress, the direction is in the upward direction. So we have to show this magnitude along this inclined line. So I will show the direction is in the upward direction, and magnitude I will mention here 60.4 megapascal. Now we will move to the second. So second angle 59.87, that means approximately 60 degree. So this 60 degree is also in the first quadrant. So if we observe, we have to consider this face, that is this vertical line, and angle is positive, that we have to move in the anti-clockwise direction. So if I move in the anti-clockwise direction, that is at 60 degree, then we will get here. So this is the line which makes an angle 60 degree with this vertical line. Now if we observe, the angle in between these two construction lines is 90 degree. That means these two lines are perpendicular to each other, and this is the point of intersection. Now from this point of intersection, I will highlight some area. Now for this highlighted area, I will draw again parallel line. Now for this line, I will draw here one parallel line, and for this line I will draw one parallel line. So we will get here. Now if we observe, we have to show the shear stress. Now the direction of shear stress is in the upward direction for this face. So for the opposite face, we have to show opposite direction, that is downward direction. Now the shear stress are in complementary form. So here the arrow is pointing towards this point. So if I draw line parallel to this face, then we have to show direction of arrow towards this point. Now for this shear stress, this arrow is pointing towards this point. Now for this face, if I draw one parallel line to this face, then we have to show arrow pointing towards this point. So this is the form of shear stress. Now the next question, we have to find out normal stress at maximum stress plane. So this maximum shear stress plane is at an angle of minus 30.125. That means here is the line. Now along this line, we have to find out normal stress. So we have to take theta is equal to, so theta is equal to minus 30.125 degree. So this normal stress at maximum shear stress plane is also known as average stress. Normal, that means perpendicular. So we have to find out stress perpendicular to this plane or this line. So how to find out? So this plane is at maximum shear stress. So we have formula sigma x plus sigma y by 2. So this is the formula applicable, that is known as average stress or normal stress at maximum shear stress plane. So when we calculate, that is 45 plus minus 60 by 2, we will get minus 7.5. So unit is megapascal. Now how to show that? So if we observe, here is the compressive force because sign is negative. So we have to show this nature is compressive and magnitude is 7.5. So I will show normal, that means perpendicular. So we have to draw one perpendicular line to this face. For this face also, and we have to show magnitude only, that is 7.5. Now we will calculate normal stress along the plane AB. So this plane AB is known as oblique plane. Now its angle is given with this bottom face making an angle 30 degree. But we know that we always measure angle from this vertical line. So if I extend this line, then we have to measure the angle of this inclined line from this vertical face. So how to measure this? So I will draw one parallel line for this face passing through the point B. So this is the construction. Now if we observe, these two are the parallel lines and this is the common inclined line. So here is angle 30 degree. And the angle in between this horizontal line and this vertical line is equal to 90 degree. So this total angle theta that we have to consider, the angle of inclination for this oblique plane, theta is equal to 90 plus 30, that is equal to 120 degree. So angle 2 theta is equal to 240 degree. Now we will move for the formula of the normal stress on oblique plane. So we have formula sigma n is equal to sigma x plus sigma y by 2. So this is the first term, plus sigma x minus sigma y by 2 cos of 2 theta. This is the second term, plus tau xy sin of 2 theta. Now from the given data, sigma x is plus 45, sigma y minus 60, tau xy plus 30 and 2 theta 240 degree. So when we put the values, then for the first term we will get the answer minus 7.5. For the second term we will get the answer 52.5 multiplied by minus 0.5. And for the third term we will get the answer minus 25.98. Now for the second term we will again multiply this, then we will get minus 26.25. So when we solve this, then we will get the answer minus 59.73. Now this stress is with negative sign. So this unit is megapascal and so it is known as compressive nature. So how to show this stress? So it is normal stress. That means we have to show perpendicular line to this oblique plane. So we have angle theta from this vertical face that we have considered. So I will show here the final angle theta. So here is the angle theta and that is equal to 120 degree. So if we consider this angle theta and at an angle, here is the oblique plane and we have to show the compressive nature. So I will draw one perpendicular line to this plane. So we have to take from this side and that is known as sigma n and which is equal to 59.73 megapascal. Now for this case we It is not necessary to show the sign because we have to show the nature of force, that is the arrow towards the body.